This is the lab video of experiment number 6, thin layer chromatography of drug components. We'll be looking at caffeine, acetaminophen, acetanilide, phenacetin, aspirin, and ibuprofen, and doing thin layer chromatography on all these analgesics. I went to visit my mom this weekend, and when I was in the bathroom, I looked in her medicine cabinet, and she has this bottle labeled Mom's Pain Pills. And she's not sure what they are, and I could not tell what they are. So I brought them back to the lab, and we're going to analyze them. And we're going to actually use thin layer chromatography to analyze them. We're going to do this by comparing it to a number of known analgesics, a number of known painkillers. So let's get started. So I went to the chemical stockroom to find some known analgesics, and what I found was caffeine, I found acetaminophen, I found acetanilide, I found phenacetin, aspirin, and ibuprofen. So now what we're going to do is we're going to mix up and dissolve a small sample of each of these in a mixture of 1:1 ethanol dichloromethane, and then we're going to proceed with the thin layer chromatography experiment. One of the first things I need to do is actually grind up some of Mom's pain pills. So I'm going to take a few of these out of here. Put them in my mortar and pestle. And then I'm just going to grind them up. Grind them up into a fine powder. Now I'm going to take each one of these over to the balance, and I'm going to weigh out approximately 0.02 grams and dissolve it in 2 milliliters of the ethanol dichloromethane mixture. So I've now weighed out approximately 0.02 grams of each of my known compounds: caffeine, acetaminophen, acetanilide, phenacetin, aspirin, and ibuprofen. Put them in a small vial. I've also weighed out 2 different samples of Mom's pain pills because I'm going to do a duplicate run of those samples. So now all I have to do is dissolve those in my ethanol dichloromethane solvent, and then we can start preparing the thin layer chromatography setup. I've now added the 2 milliliters of ethanol dichloromethane to dissolve each of my samples, and they seem to all dissolve fairly readily. Here are my notebook pages documenting what I've done so far and the weights of all my samples.
I've taken away the bottles from the stock room and just left my samples here and got them in the same order that I had them in. Now I need to make up my development chamber, and that's going to use some dichloromethane, and I'm going to use some ethyl acetate, and I'm going to mix those in a ratio of 3:2, ethyl acetate to dichloromethane.
So this is our setup for the development chamber. I have my 3:2 mixture of ethyl acetate and methylene chloride. I have a 400 milliliter beaker. Inside that 400 milliliter beaker, I'm going to put a piece of filter paper that I've cut up. This is going to allow liquid to wick up that filter paper and help saturate my atmosphere inside that chamber. I'm now going to take 10 milliliters of my dichloromethane mixture and put in my development chamber. Putting that down on top of there. Okay. And then on top of that, I'm going to put a piece of parafilm, just to sort of keep that all sealed up. And I'm going to put a watch glass on top of that just to hold it down. And so now this is just going to be set aside until we got our TLC plates all ready to go, and we'll use this as our development chamber. You can sort of see that the liquid is starting to wick up the filter paper there. So here are my silica plates. They're already pre-prepared. So they have a silica gel that's been cast onto them, onto pieces of aluminum. They're approximately 5 by 10 centimeters in size, and we'll be using these for our experiment today. I'm now going to take 2 of them out, mark them up with a pencil with my lanes and my baseline, and then we can start spotting them. I've now made up 2 TLC plates, being careful not to touch them except with the tweezers at the top. You can see that I've marked lanes in there. In this TLC plate, it says 1, 2, 3, 4 with a little dash, and I've marked the baseline. And here is my second one that's labeled 5, 6, 7, 8. Here are my 2 TLC plates. I've drawn a straight line with a dull pencil approximately 1 centimeter up from the bottom. I've then marked out some hash marks on that line, and below each I've put some numbers. And I'm going to be spotting now at the intersection between the vertical hash marks and the horizontal baseline. I also have some capillary tubes here that are pre-manufactured. These are approximately 75 milliliters long, and they have a 0.4 millimeter ID. I'm just going to take one of them out. So these are just a small glass tube that's open on both ends. If I were to stick that in a liquid, just due to surface tension, it would wick up into that small capillary tube, and then when I touch it to the TLC plate, some of that liquid would wick back out and be absorbed onto the TLC plate. So we're literally going to now go around and use these small capillary tubes to sample each one of our known compounds and our 2 unknown compounds, Mom's pain pills, and put them on the TLC plates in the order that they're listed on my lecture notes. We're going to do Mom's pain pills 1, then we're going to do caffeine, acetaminophen, acid amylate. Then we're going to do phenacetin, aspirin, ibuprofen, and lastly, we're going to do our second sample of Mom's pain pills, just to be a repeat experiment.
So the first thing I'll do is I'll take sample number 1, which is our unknown analgesic. I put out specifically little capillary tubes for each one so I don't get them mixed up. I'm going to stick my capillary tube down into the liquid. It wicked up about that far, so it wicked up about 1.5 inches. Now I'm just going to touch it at the intersection of my lane and my starting line, and a little spot appeared. And I'm going to do that 3 times in the same spot, just so I can get enough material on there. Okay? That one's done. Now I'm going to move on to caffeine. I'm going to put that in lane 2. Wick some up. Go to lane 2. Touch it. Touch it a second time. And we'll do the same for all of our samples here. I've now placed a spot of each sample onto our TLC plate. In lane 1 is mom's pain pill. Lane 2 is caffeine. Lane 3 is acetaminophen. Lane 4 is acetanilid. Lane 5 is phenacetin. Lane 6 is aspirin. Lane 7 is ibuprofen. And lane 8 is another sample of mom's pain pills. We're now going to take our plates over to the UV light to see if we have enough material spotted on each of our lanes. This is a UV light source which has a chamber in it. We can put our samples into the flap down on the front and then look through the goggles there to actually visualize our TLC plates under UV light. Under the UV light, each of our spots appears as a dark circle. That is because most organic compounds strongly absorb UV light, resulting in a dark spot. That is visualized now. I'm going to remove the watch glass. I'm going to remove my parafilm. I'm going to take our first TLC plate, put it down in the liquid, replace my parafilm carefully without moving my development chamber, and you can see the liquid starting to move up the TLC plate, and it's just about hit the starting line right now, and it's just past it. So as that solvent front moves up, it's going to grab those materials and they're going to move up the TLC plate. How far they move up depends on their polarity. Our solvent is a mixture of ethyl acetate and dichloromethane, so it's got polar and nonpolar components, and our silica gel has a polar component to it too. So we're just going to continue watching this develop.
I can see that my solvent front has reached about 2/3 to 3/4 of the way up the TLC plate. So I'm now going to remove it, and I'm going to mark that solvent front with a pencil. And we'll let that dry. In the meantime, I'll take my second TLC plate and start developing it. Carefully put my parafilm back on, cover it with my watch glass, and we'll wait. I'll turn off the video now. We won't have to watch this one all the time. We'll come back when it's done. Our second TLC plate is developed approximately to the same height. So I'm now going to remove it carefully. And again, marking the solvent front with a pencil lightly. Once these both have dried, we'll take them over to the UV light to visualize the spots that have moved up the TLC plate. Here are the two plates under the UV light. It's a little bit hard to see some of the spots, and so I will circle them and mark them with a pencil and then show another picture of those. But you can clearly see spots have moved up the TLC plates. So I've used a pencil and I've drawn around each of the different spots that I observed under the UV light. Some of my spots are very defined and circular. Some are sort of oblong and sort of like spots have been dragged up. I have marked the top of each of these spots too. So in lane 1, I see two spots, one circular and one sort of oblong. I've marked both the tops of both of those spots. In lanes 2, 3, 4, and 5, I have very well defined circular spots. In lane 6, I have a very long spot. Lane 7, a long spot, but not quite as high. And in lane 8, I have two spots again. One that's well defined and circular, and one that's dragged out. Here are my final 2 pages of my notebook, documenting my procedure that I did and any observations that I had during the experiment. I've placed a ruler next to my first TLC plate, and you should be able to measure the solvent front in this image. Here is a ruler next to lane 1 markings. The ruler next to the spot in lane 2. Lane 3. Lane 4. The solvent front for my second TLC plate.
Lane 5, Lane 6, Lane 7, and Lane 8. These images will be available as individual slides on Blackboard.